Well, good morning, geometry. This is April Fool's Day, and I know I'm not here, but you still have work to do. So there's my April Fools. I'm not here, but we're still taking notes on the next section. So when I come there, hopefully on Monday, you will get your test back, and we'll go from there. So I'm going to try to go slow on these notes. I might even read you a problem if I feel I need to. Make sure you have your note sheet in front of you, and we're going to get started. So the first thing here today we're going to talk about is what an inscribed angle is. Now you all know what a central angle is, but now we're going to talk about an inscribed angle. An inscribed angle is an angle that has its vertex on the circle. An angle that has its vertex on the circle and its sides an angle that has its vertex on the circle and its sides are contained as chords of the circle. An angle that has its vertex on the circle and its sides are contained as chords on the circle. So if you look at the circle over to the right, the inscribed angle is angle DEF. Now this is different than a central angle because central angles come from the center of the circle. So over here on the right, this vertex is on the edge of the circle. So that's really important that you understand the difference between inscribed and central. So then there's this theorem here, but you have to know how to apply it. It's called the inscribed angle theorem, and it says if an angle is inscribed in a circle, and here's the important part, the measure of the angle equals 1/2 the measure of its intercepted arc. And it says it right here. So if I tell you all the measure of arc, let's say DF, is 60, the inscribed angle, the measure of angle DEF, according to this theorem, is half of that. So the inscribed angle is 30. So let that sink in for a second. If you have an inscribed angle, the measure is half of it. Half of the arc is the measure of the inscribed angle. My screen needs fixed. All right. So the next thing here it says is an inscribed polygon. And you've seen that word before because I know some of you have asked me what that means. An inscribed polygon is a polygon whose sides are chords of a circle and the vertices are points. So all that means is when it's inscribed, it touches the circle. Polygon ABC is inscribed in that circle. There's no point in there. And this is a major thing here. If an inscribed angle intercepts a semicircle, the angle is a right angle. So let's reason this picture over here. CB is a diameter of this circle. Angle CAB is inscribed. So CAB is inscribed. The measure of arc CEB is 180, and you all know that because it's a semicircle. So it says every time you have an inscribed angle intercepting a semicircle, the angle is a right angle. So this means the measure of angle CAB equals 90. So I'll say that again. CAB is inscribed. It touches arc CEB, which is 180. So anytime an inscribed angle intercepts a semicircle, it makes a right angle. This statement here says if a quadrilateral is inscribed, that means the vertices touches the edge, then its opposite angles are supplementary. So you should know they add up to 180. So in your picture to the right, in circle R, there is quadrilateral ABCD. This means the measure of angle B, and you have to look for the opposite angle, which is angle D, has to equal 180. And the measure of angle A, and the opposite angle is angle C, is also 180. And that's the gist of today's lesson, inscribed angles. So let's now put it to use. Number 1, it's asking you to find the measure of an arc, this arc down here. It tells you the inscribed angle. So you all know the measure of ABC is 36. According to the theorem, the inscribed angle is half of the arc. So the measure of arc AC is 72. So make sure you understand that. You're just going to double it. If we go to number 2, this 62 is arc KL or LK. So the measure of angle N has to be half of 62, the arc it intercepts. So the measure of angle N equals 31. And the last one, QSR, here's QSR. Now first off, that is a major arc. That is a major arc because there are 3 letters. The measure of the arc is twice this inscribed angle. So we're going to take 113 multiplied by 2 to get 226. Because the inscribed angle is half of the intercepted arc. So you have to go the opposite direction to find this one. I'll give you a minute to look at that before I turn the paper. Those are just 3 basic ones. The harder ones are on the back, which are more thought. Okay, so for 4 and 5, it says use this circle P. When I look at circle P, something that I notice that I should pay attention to is AC is a diameter. So that means there is a semicircle here. Remember, when you see a semicircle, the inscribed angle is always 90 degrees. So there is a 90-degree angle there. If you don't know that, then you're lost on how to do this problem. Because every time an inscribed angle, this is inscribed, touches a semicircle, it has to be 90. So, to find the measure of angle A, I need to know x. And since that's a right triangle, I know 3x plus 6 plus x equals 90. Now, if you want to add 90 and then set it equal to 180, you can. But I'm just setting these 2 angles equal to 90 to solve for x. Either way will work. So you should be solving for x. This is your strict algebra. And when you solve for x, you get 21. So if you know that x is 21, you can just substitute it back into 3x plus 6. So 3 times 21 plus 6. That gives you 69. So the measure of angle A is 69 degrees. It also asks for C. C is just X. So the measure of angle C is 21. All right. Next example. We're using this circle B over here to the right. Notice that there is no semicircle over here. No semicircle. So we don't have any inscribed angles being 90 degrees. However, you see this arc here, ZY? There are 2 inscribed angles here. I'm going to do one in pink. This is an inscribed angle right here. And then there's one, I'm going to do it in blue. This inscribed angle here. Both of those inscribed angles, I'm going to get rid of the colors in a minute, they touch this arc. That means they have to have the same measure. So you see the 22 degrees? Let me get rid of this real quick. There is a 22 degree right here. That means this inscribed angle has to also be 22 degrees. Why? They both touch this arc. And you all also know the measure of that arc. The measure of that arc is double the inscribed angle. So that is 44 degrees up there. So we're going to start with that. I come over here and it says, what is the measure of angle W? I know the measure of angle W has to be 22. All right? Now I'm going to get rid of these markings to show you how to find Y. Because if you look at Y, that's in here, right here. So let me get rid of these markings. I'll use pink this time. Inscribed angle Y is right here. If you notice, I'm going to grab orange. Inscribed angle Z right there. Hopefully you realize that they both touch the same arc down here. So when these 2 inscribed angles touch the same arc, those inscribed angles are congruent. Why are they congruent again? Because they both are inscribed to the same arc. So to solve for Y, we're just going to do a math problem where we set 3x minus 23 equal to 2x plus 2. And then you're just going to solve your algebra for x. X minus 23 is 2. Add 23. We get x equals 25. So since x is 25, to find the measure of angle Y, we're going to sub it back in. It says 2 times 25 plus 2, that gives us 52. Therefore, the measure of angle Y is 52. So this example was to get you thinking, anytime you have an inscribed angle that touches the same arc, their measures have to be congruent. All right? The next example here says for 8 and 9, use this circle N. When I look at circle N, I do not see a semicircle, but you should notice something about the figure drawn inside. This is quadrilateral, HEFG. Or you can name it a different way. However, it's a quadrilateral. We learned something on the back of your notes. On the back of your notes, it said opposite